Hello everyone. We shall practice now integrals involving the natural exponential function. How to integrate this function? Well, we know the derivative is very simple. The function coincides with its derivative. So when we take antiderivative, you get the same function, but also we put plus c for general antiderivative. And now let's see examples from the book. Here is number 84. Evaluate this integral between negative 5 and 5, integral with limits, e dx. So how to understand this? We integrate actually a constant. E is Euler's number, which is approximately 2.7, and dx says to integrate with respect to x. Well, this constant we can pull outside, and we integrate 1 dx, which is just x, so we have e times x plus c. And we have to take this between negative 5 and... Actually, we don't need this c. Sorry about that. I was carried out. Just put limits. Negative 5, 5. For x is a constant. So this will be e. First we have 5, then minus negative 5. And this is actually 10 times e. 10 times Euler's number. Simple example. It's important to read correctly what is given here. Number 86. Evaluate this integral. X squared exponential power x cubed dx. Now this is an indefinite integral. We have to find antiderivative. Okay, we have here this product, and after short inspection we see that we have to do a substitution. We set u to be x cubed because this is the most disturbing x cubed here. Then du is 3x squared dx. If we write the integral with the exponential first, x squared dx, you see this product here, x squared dx, and x squared dx will be 1/3 du. Then the integral becomes 1/3 e to the u du. And since we integrate according to a variable u, and we have e to u, this is the same exponential eu. And now we write plus c because we need general antiderivative. There is a third step. First step was to introduce a new variable. Second step is to find the relation between the x du. The third step, return to x. So we continue and write 1/3 exponential x cubed plus c, our general antiderivative. Every time when you do substitution, there are 3 steps. Okay. I want to show you a shortcut. Shortcut how to solve this problem. Sometimes it's good to do this. The previous computation shows that du is 3x squared dx. So we can simply consider x squared dx as the derivative x cubed over 3. So this is how we work. Just a moment. Ex cubed x squared dx. We integrate x squared, moving behind this integration. Remember that f prime dx is df So we can write this exponential x cubed dx cubed over 3, which will be 1/3 outside integral exponential x cubed dx cubed. Now we can think of x cubed like our new variable. It was u in the previous work, but we don't need to introduce a new letter. Just think of this like u, and integration will give you 1/3 exponential x cubed plus c. So we did this without writing new letters. And sometimes it's good to do this because it saves time. Moving to the next example. Here is number 88. Solve this integral. Again, indefinite integral. 1 plus e to power x, all this squared, and divide by e power x dx. How to solve this integral? Now, we can make a substitution. Replace this thing in the square by a new letter. And let's see how this works. Let's say u equals 1 plus e to the x. Then du will be ex dx, that's all. Dx will be du over ex. And then our integral will become integral u squared. There is one ex here. And then we have dx replaced by du over ex. And this becomes exponential integral u squared du over e to x. And now we're wondering what to do with this e to x. Integral did not turn into integral only of u. When you make this u substitution, you want everything to be written in terms of u. So it doesn't work this direction. The substitution is not helpful here. So what to do? What to do? Well, this is what we shall do. We shall simplify the integral. And we take integral 1 plus ex squared over ex dx, and we work the square on the top. Remember, formula of perfect square, a plus b squared, that's a squared plus 2 times ab plus b squared. So a is 1, b is the exponential, so we go 1 squared, that's just it, 2 times the product, 2ex, and e to x. When you square the exponential, you get this. And all this divided by e to the x dx. Okay, continuing here, we now divide each term by the exponential. 1 over ex plus 2, just 2, plus e to x over ex dx. And this will be e negative x plus 2 plus ex dx, because of the property of the exponential. E to x divided by ex, that's exponential, 2x minus x, that's exponential just x. And now we can integrate term by term. What will be the antiderivative of e negative x? This will be e negative x over negative 1. And I shall explain about this after the example. Then we have 2x, then we have ex itself plus c. So let's write this way, negative e negative x plus 2x plus ex plus c. That's our antiderivative. Okay. Now, about this first integration. Remember that if we have exponential ax, a some constant, the derivative will be constant in front, exponential ax. If we integrate exponential ax, the x, whatever constant a is, this will be exponential ax divided by this constant plus c. Because if I take the right hand side and differentiate, let's compute the derivative here. The derivative of c is 0, of course. This will be on the top a exponential ax. This a we ignore, it's a constant. A cancels out, that's our integrand. So we have our exact antiderivative. Here is a convenient rule we can use without having to do substitution from time to time. Another example, let's say you have to integrate exponential 3x dx. You go immediately, rewrite the exponential, divide by this coefficient. That's it. No need to do a substitution. Good. Now, let's do example 90. This is integral exponential x times 4 plus e to the x fifth power dx. Now, expanding this fifth power is possible but not desirable. That will be a long expression, very unpleasant work. And now we shall try again substitution, hoping it will work well. So we set u to be 4 plus e to the x. Du will be ex dx. And fortunately we see this product ex dx here, so we can replace it immediately by du. And the integral becomes u fifth power du. Perfect. Using power rule, this is u 6 power over 6 plus c. Returning to x now, let's write down 6 like that. What was u? 4 plus e to the x, now 6 power plus c. This is our general antiderivative. Very well. Now, we shall do many other examples later. For the moment, I think this is sufficient. And in our next lecture, we shall talk about exponentials and logarithms to different bases. We shall discuss functions like 2 to the x, 10 to negative x squared, or what is logarithm base 5 of x next time. Goodbye.